Hello everybody, I am Paolo Peser and welcome to potentially one of the last episodes of GenExpr for musicians. In the previous video we saw four very important operators: the buffer, the data, the history and the param operators. We saw how to declare them and some of the things that we must know in order to use them properly. So in today's video instead we will look at the declaration of functions and then the calls of the libraries. So let's not lose another second and let's dive in. Okay, so let's start with a short definition of what a function is. Function, and I read, is a block of code written in a specific format that users can declare with a name and call as many times as they desire. A function can take inputs and return one or more results, so that different data can be processed with the same logic. In GenExpr, the functions either need to be declared before the operators buffer, data, history, and param, or to be saved in libraries that can be called with the command require and then the name of the library. Now let's look at this pseudocode that I prepared so that you can understand how to declare your functions. First is the function name, then in between parentheses the name of the parameters, which we refer to the internal variables of the series of statements that we want to make, which will be in between the braces. And after the statements we will have the command return, which will return the state of specific variables that we stated in our statements. Now notice that return not only returns the state of the variables that we want it to return, but also concludes the reading of the code. So whenever a return is encountered, the compiler will not read the function further. Now, one thing about the operators that we saw in the previous video. Data, history, and param can be declared inside a function, while buffer cannot. But how then we work on the data that is inside a buffer? Well, we use the name of the specific instance of the operator buffer that we have, and then we use it we use it as an argument for the function in one of these parameters slot, so that we can access and we can do certain operations on that data. Now you noticed one thing: I call this parameter an argument because when we declare the function, it's called parameter. When we are calling the function, those values or those variables that are carrying the states which we want to bring to send into the statements of the functions, then a parameter is called argument. I hope it is clear. Okay, so let's continue and let's look at a characteristic of the param operator, which is if we want to access the param operator inside of the function, we need to use the argument syntax. So we need to do my param equals, and then it can be equal to another param operator inside the same gen environment same gen patcher in which there is the function. Or it can be an expression, but it can never be a variable of any kind. So whenever you're using a variable, it doesn't work, but if you're using a param, it works. If you're using an expression, it works. So yeah, you have some options. All right, let's move on. Let's look at the code and the function that I prepared for you. So I declared the function named myfunc, which has input1, input2, and buffer name as parameters. It has an internal param named myparam, a variable named add that is stated as input1, the expression input1 plus input2, and then that returns the value, the state of head, the length of the buffer, and then the value of my param. Now we look at the code here. We know the drill. I declare the buffer. I declare the parameter inside the gen.codebox tilde object. And I stated the argument 1, argument 2 as in1 and in2. And then I have out1, out2, and out3 that equals the return value of the function myfunc, which is receiving arg1 as argument 1, arg2 as argument 2, the name of the buffer operator chow, and then argument syntax for myparam, the internal parameter inside the function, and varparam, the one outside. Now, in1, which is 2, plus in2, which is 2, makes 4, and indeed out1 is 4. Then the length of the buffer, as if you remember, it was 100 milliseconds, thus 4,800 samples at 48K sample rate. And finally, if we change the value of our param, we see that out3 changes as well. All right, so this was about functions. Let's look at cause of the libraries. By saying what libraries are, because they are files in which all your functions, part of your functions, are contained. They can be called with a command require, and give the user access to all the functions inside them. To call a library, save it as a library name.genexpr in a folder included in the max search path. In GenExpr, libraries need to be called before anything else. So the order is libraries, functions, the operators buffer, data, history, and param, and then all the statements that we want to make. Now, one specific note, because some time ago, I made a feature request asking for the possibility of nesting libraries one into the other, so that, for example, if we have the function named myFunction inside library A, and we call library A inside library B, and then we call library B inside our code, we have direct access to the function myFunction that we wrote and that we saved inside library A. What I discovered while preparing this video was that the feature that I requested should already have been present inside the GenExpr, because actually what I encountered, the fact that this feature was missing, was actually a bug. In theory, GenExpr should already permitting the user to do such a thing, but unfortunately it is not the case at the moment, or at least per max 9.1.1. I believe that it is something that will be solved very soon, so I wouldn't worry too much about it. Just be aware that this bug is present and you cannot nest libraries one into the other. Now, let's look at the code. Here I am calling my library, GenExpr for musicians, which has a function that is identical to the one that we saw some minutes ago. So we can expect that in1 plus in1 equals 2. 1 plus 1 equals 2. So out1 is 2, again for 1,800 samples. And then if we change var param, out3 changes. Okay, so with functions and libraries, we finished. There are some things that I want to show you in some minutes, but before arriving there, since I didn't know where to put these except two things, I want to talk about them. The first is that if we want to reset the patcher and the GenExpr code at its initial state, we can just, or better saying, if we want to reset the variables and the history and parameters and so on to their initial state, we can just use the message reset that goes inside the gen patcher or the gen.codebox tilde. So indeed, out3 became 0 again. The second is that we can enable and activate and deactivate the code that we are using. As you remember, I mentioned in the very first episode. So if I put enable 1, the code is still working, we can still see the values, but if I put 0, the code is not working anymore. So this is pretty handy. Okay, so let's move on to the very final part. I discovered two bugs that shouldn't be here, but they are. The second I already reported it some time ago, while the first I discovered while making the video for this episode. So the first one, let's show you the functions that I prepared. So the functions that we're going to see is pcheck, which is just returning the values of the arguments directly in a direct way. So as you see, input 1, input 2, and then return input 1 and input 2. And then we have a tremolo, which is tremolating a signal, and with a specific depth and with specific rate. Now let's close it and let's look at how I constructed this thing. So if we put two instances of that code pcheck that is returning directly the state and the values of the arguments in the same line, as in this case divided by comma, the inputs are not correspondent to the output. So we should have 1101 also in the output, but instead we have 1000. The curious thing is if I change input 3 to 1, then input 2 becomes 1. It should be input 3. I think I will report right after making this video. So yeah, it is something, just be aware of it. But if instead we break the line in two different lines, actually the two functions are behaving as expected. So 1011 is indeed 1011. I don't know exactly why, but this is it. Now to the one that I already reported. Now you notice one thing. We are calling the function through the library, and we have that out1 equals the first instance of ptremolo, and then out2 the second instance of ptremolo. The curious thing is that the signal and the depth are the same, are constant 1 for both the arguments and both the instances of the same function, but the rate is different, so we should expect a different rate. What is happening though is that they sum together instead, which is a bit weird. However, if we just declare the function in the Gen code box, we can see that the two rates are indeed different. So I can just, and the one will not fed the other. So yeah, just again, take it as something that will probably most likely be solved soon. So yeah. Okay, so for the video of today, this is it. As mentioned, this potentially is the last episode of GenExpr for musicians, although if there are perhaps doubts or other ideas, I can make another one, a sixth and a seventh, and we can go on until there is actually material to look at. Okay, so if you have doubts, comments, feedbacks or requests, leave them down below. It was a pleasure to have you here in this small journey that GenExpr for musicians have been. I hope that you enjoyed it and that it would bring you to write GenExpr code that will bring you much fun and joy. So again, Thank you for being here. I hope that you're going to have a fantastic day, afternoon, or evening. And see you next time. Ciao.